Yeah, good day, my fans out there. I remain your chemistry lecturer on social media by name Dr. D.I. Zoom. We have been dwelling on scenes of state of matter. And, the previous lectures we discussed was on vapor pressure and the boiling point. Now, what we discuss right away is freezing and condensation. Freezing and condensation. This probably will be the last topic. Then the next, we'll go into kinetic theory of gases. That is gas, specifically gas. And when we have done with that, we go into gas laws and then their calculations. So listen carefully. And those of you who are chemistry students out there, please get a biro and put something down. But the level of your understanding will increase as we keep on playing this all the time. Freezing and condensation. Now let me give you what I have here. While heating, when you are heating something, you apply heat, it causes melting and boiling. If you apply heat to a cube of sugar, which is solid, as you continue to heat it, it will begin to melt in the first stage. If the heating continues, it begins to boil. On the other hand, cooling causes condensation and freezing. Now, if a vapor, a gas, is cooled to some extent, the vapor becomes liquid. But if the cooling continues, it condenses and freezes to an ice block like water. So, while heating causes melting and boiling, cooling causes condensation and freezing. Now, condensation is the process whereby a vapor loses some of its kinetic energy to a cooler body and then changes into the liquid state. I take it again. Condensation is the process whereby a vapor and its gaseous state loses some of its kinetic energy. And then as it loses kinetic energy, what happens? It comes down to a liquid state. So when a liquid is further cooled, it loses the heat energy to the environment or the surrounding. And what happens? It will now, the temperature will drop. If the cooling continues, the temperature of the liquid keeps dropping until it will reach a point which is called the freezing point of the liquid. At this temperature, the liquid changes into solid state. That's why you have the ice block. Now, on the other hand, the normal freezing point of a liquid is therefore the temperature at which solid and liquid are in equilibrium under a total pressure of 1 atmospheric pressure. Take it again. The normal freezing point of a liquid is the temperature at which solid and liquid are in equilibrium under what? A total pressure of 1 atmosphere. So at freezing point, the temperature of the solid liquid system remains constant until all the liquid is frozen. So the amount of heat that must be removed to freeze a mole of a substance at the freezing point is called molar heat of crystallization. Molar heat of crystallization. Molar heat of crystallization. So that means that is the amount of heat or the quantity of heat required to remove so that the freezing of a mole of a substance at the freezing point. All right. Now, the temperature at which a gas cannot be liquefied by pressure is called the critical temperature of the gas. There are some gases at a point that the temperature cannot liquefy the gas. So that temperature at which a gas cannot be liquefied by pressure is called the critical temperature of the gas. Now, the pressure required to liquefy a gas at its critical temperature is called critical pressure. Critical pressure. Now, let me give you a diagram here first before we continue. Now, take a look at this diagram. Is solid, is liquid. Now, this is state of state, right up. Now, this is condensation. This is evaporation. This is freezing. This is melting. This is sublimation. Now look at it quickly because there's no time. Now, from the solid, when the solid melts by heat, the particles lose and it forms liquid. So it will now transform from the state of solid to liquid. Then this same liquid, if it is cooled, if the temperature is cooled beyond a reasonable doubt, it will now go back through freezing to solid. Then solid, sometimes when it's heated, it goes to vapor direct. Remember, I discussed sublimation. Iodine does that. So by sublimation, iodine as a solid, when heated, goes straight to the gaseous state. Then gas, because the molecules are far apart, the forces is negligible. But if the forces, if this gas is condensed, it will go back to the liquid. And liquid, when it heated and evaporates, it goes back to the gas. So this is how the cycle continues. And this is what we call the change of state of matter. Change of state of matter. Please like it, comment, and follow me. Also subscribe to my YouTube channel. You can even download it from there. God bless you. How many minutes?